So let's talk about required practical number 2, titrations. So if you've done it already, you'll know that it looks something like this, and it is a way of accurately working out the concentration of an unknown liquid. Conc of an unknown liquid. Or solution, I guess. So let's have a bit of a walk through the equipment. So my unknown liquid in this case is in this flask at the bottom. So this here is an acid of unknown concentration. And I would like to find out how concentrated it is. This tall glass thing here, that is called a burette, and it is a way of adding a liquid and very accurately determining the volume of liquid that you're adding to the flask at the bottom, which neatly brings me on to this piece of equipment just here. This is a conical flask. And finally, this at the bottom, this might not seem like terribly much, but you need some sort of white base for reasons that we will talk about later. I use a white tile. In this case, it looks like paper. Okay, and this picture has come from the very nice people at Wiki Commons, as have many of my pictures today, so thanks very much for that, guys. So, what do you do? Well, there are a number of steps to this, but step number 1 is you have to accurately measure out a volume of your unknown solution. So let's say that I am going to put in, I don't know, 25 centimeters cubed in here. That needs to be accurately measured out. Okay. And then what I'm going to do, because I said earlier that this was an acid, I am going to need to fill up my burette with an alkali of some kind. Okay. So this alkali, I will know the concentrations. That's a known conc. So I will actually know what the concentration of my alkali is. And then what I'm going to do is I'm going to turn this little tap thing here at the bottom, and I'm going to slowly add my alkali, and I'm going to find out exactly how much alkali it takes to neutralize my acid. So that is step number 1. You've measured out your volume of an unknown solution, and step 2, you've filled the burette. Now, in this case, I've done it with an acid and an alkali this way round. You could easily have the alkali at the bottom and the acid up in the burette. This is just the setup that I have picked. Now, step 3, you're going to need some sort of an indicator. You're going to need to add an indicator. Well, why do you need an indicator? Well, in this reaction here, I'm adding a colourless alkali to a colourless acid. I know it looks pink there. We'll get onto that in a second. And it's very difficult to know when exactly you have completely neutralised your acid with the alkali. So you need an indicator to show when that has happened. Now, the indicator which I have picked for our little chat just now is an indicator called phenol, and this is a pain in the neck to spell. I've spelled it right today, brilliant. Phenolphthalein, that is the name of the indicator. Now, when it is acidic, it is colourless, and when it is in a basic solution, so something with a pH of larger than 7, something between 7 and 14, it is pink. So what you do is you start with a colourless liquid at the bottom. You add your indicator and it is colourless, because remember we're starting with an acid, and then you slowly add your alkali Well, if you kept adding and adding and adding, eventually it would turn pink. But what you're really after is the first permanent pink. The very first pink colour that holds, because you're gonna be swirling this as you go, as you add your alkali. And actually, let's try that again. My terrible handwriting. Permanent. That's better. Yeah. So that permanent pink tells you that you have successfully neutralised your acid by adding exactly the right amount of alkali, not too much and not too little. So that is what step 3 is about. Step 3 is about adding your indicator. Now, step 4 is going to be your white tile. Now, remember, what you are looking for is the very, very, very first permanent pink colour. And without a white background, that's really difficult to spot. It's why this experiment here has got this white base to make it a little bit more obvious. Okay, so you've got a white tile. Step 5, you note the start volume in the burette. Now, very, very often these will start with a volume of 0. So you would have your burette like so, and very often you will have filled up your burette to the 0 point with acid. Now, there's an important little point to notice here. When you fill up the burette with a liquid, you'll notice that you get this dip like this, and that's called a meniscus. So when you are measuring a volume in a burette, you need to make sure that you measure from the bottom of the meniscus. Not only that, but you've got to get along sort of exactly alongside it. So this is somebody's eye. Yeah, it is. It's someone's eye. That's their eyelashes. Yeah, there. Yeah, that's 9. That's fine. And you need to make sure that you are looking at it from dead on at the side, so that you don't get something called parallax error, which you would get if you were trying to read it from too high. Let's say it would look different to how it is normally. So that is what's called a parallax error. That's why you've got to be alongside it. So you've got to be alongside it, and then you've got to watch out for this meniscus and make sure that you read from the bottom of it. So you've probably filled up your burette up to the 0 mark with acid. So that is your start volume, and you have made a note of it. Step 6, add the alkali. So you open up the tap just here, and you let the alkali start to run in, and all the time you are swirling that flask at the bottom, helping all the chemicals to mix together, the neutralization reaction to happen, all the while looking for your first permanent pink to emerge. You then will reach an end point which in this case will be a permanent pink colour, your first permanent pink. But if you use a different indicator, it will be a different end point. They each have their own different end point. Step 8, you note the volume used. So if I started at 0 centimetres cubed, and then it went all the way to, I don't know, 27.6 centimetres cubed, I know that I have used up 27.6 centimetres cubed of alkali. It may also say mil on the side of a burette, but for our purposes they are basically the same thing. Okay. The final thing to mention here is that your first one is rough. So your very first titration you will do quick. You'll open up the tap, run it in, and you will probably end up with quite a dark pink if you're using phenolphthalein, and you'll end up with a value that's something like, I don't know, so your rough titration is going to be something like 30.8 mil of alkali used. Now that is, like I say, it's a rough value. It is going to be somewhere in the ballpark of the right amount, but it's not accurate enough for our purposes. So what you've got to do is you have to do it again and again and again. And what you are looking for is concordant results. So basically you've got to keep going until you get concordant results. Now concordant is just a fancy way of saying in agreement. So if you got a result of, let's say, 20.7 and 20.6 mil, those would be concordant because they are within 0.1 mil or 0.1 centimeters cubed of each other. Okay, so they have to be concordant, and you have to keep going until you get to that point. Now, what you then actually do with this information, the fact that it has taken, I don't know, 20.7 centimeters cubed of alkali to neutralize your acid, what you then do with that, well, that is a story for a different video. But what we'll do now is we'll just sort of recap the steps really quickly. You've accurately measured a volume of a unknown solution into the flask at the bottom. So in my example here, I picked an acid. You then fill the burette up with something that's going to react with it, so an alkali. You then added an indicator so that you know exactly when the alkali has neutralized the acid, when you've added enough for that to occur. You then add a white tile underneath to make the end point a little bit clearer. You open up your tap, you start your alkali running in, and you note the start and the end values, and then you can work out how much alkali you used. Your first one is going to be very rough. Subsequent ones following that, you're going to be a lot slower and a lot more careful, and you are going to keep going until you get some concordant results. Thanks very much.